All right, so in this part two, for combination of functions, we have these two linear functions. They're linear functions. You understand they're linear, right? But but we consider those polynomial, correct? All right, so I'm looking at two polynomial functions. Number one. So we're going to start. In the previous lesson, we evaluated them at numbers. Here, all I'm going to do is just add, subtract, multiply, and divide them. And then we're going to find the domain of each part. That's the idea here. Okay, now remember though, in order to be able to do these, you have to know your definitions for combining functions. For example, you have to know that if you have f plus g evaluated at x, that's the same thing as what? F of x plus g of x. And you also know that addition is commutative. So g plus f at x would be the same thing. F minus g evaluated at x, by definition, remember subtraction is not commutative, so the order in which you write it doesn't matter. What must I put first? F of x, since f is listed first, and then there'll be minus what? G of x. Okay, here's the question I'm going to ask you though. Suppose I had this. I'm going to put it right here on this side. Suppose I put g first. Would this answer be the same as that answer? Chances are not. Okay, unless those two are the same expression. But for us, the function is going to be different. By definition, what is this? All right. So remember, subtraction is not commutative, so the order doesn't matter in which you subtract. These two, since our function is going to be different, these two answers will be different. You have to know that f times g evaluated x equals what? Good. F of x times g of x. And multiplication is commutative. The order in which you multiply does not matter. And then division, f divided by g at x is equal to what? F of x divided by g of x. Division is not commutative. And it kind of makes sense because if you had g divided by f at x, then what's going to be in the numerator this time? G of x. And what's the denominator? F of x. Okay. So knowing that is going to help you with what we're about to do, knowing these definitions. Number one, what would f plus g at x equal? Notice in the previous lesson, you did this. You found f plus g at 5, let's say. But I just want to know, evaluated x, what that equals. By definition, what is that?
F of x.
Okay, f of x
Plus g of x.
plus g of x. And remember in the previous lesson, what you did in the previous lesson was when this one was this one, I'm sorry. In the previous lesson, what you did was once you found, see here in the previous lesson you were evaluating at a number. Here that's not a number, that's a variable. And so when you wanted to find g of -3, you went to your function, and wherever you saw the variable -3, wherever you saw the variable x, you substituted -3. And then you came back and you put those values under these two functions. You make that same connection with this. So basically, you're asking yourself, all right, I want to find f of x plus g of x. Do you know f of x? Yes, you do. What's f of x? 3x minus 4. So that goes here. Plus, do you know g of x? Yes, you do. What's g of x? X plus 7. And all you do is combine your like terms, and there's your answer. What do you get? 4x plus 3. So f plus g evaluated x equals what? 4x plus 3. It kind of makes sense because what am I doing to those two functions right here? I'm adding them. You combine your like terms. 3x plus x is what? 4x. A negative 4 and a positive 7 is what? 3. There's the word, but you could have done this in your head, couldn't you? Okay. Notice, I want you to notice something. I have a polynomial function, I have a polynomial function. When I added these two polynomial functions, I ended up with a what? Polynomial function. Now here's the question. What is the domain of f plus g? All real numbers. Isn't that a polynomial function? All real numbers. All right, so you learned that from a previous lesson. All right, number 2. See, it's not that difficult. Let's do subtraction. F minus g at x. F minus g at x. What is f? I'm sorry. How do you rewrite this? Excuse me. Let's do that first. How do you rewrite it? F of x minus g of x. All right, now I got to find out f of x first. What's f of x? 3x minus 4. Now be careful with the subtraction. See, you're subtracting, right? So the way you want to do this is this. So you're going to bring the subtraction symbol down, but you're subtracting g of x. G of x has how many terms? 2. I got to subtract each of those terms. So put that in parentheses to begin with. So put g of x in parentheses. What goes here? X plus 7. Now get rid of the parentheses by distributing that negative symbol. So I get 3x minus 4 minus x, not plus 7, minus 7. Okay, so that's why it was important you put that in parentheses. Combine like terms, you get 2x minus 11. So you just found f minus g at x. You understand? Now, what's the domain of f minus g? Well, yeah, because look, it makes sense because f is a polynomial function, g is a polynomial function. When I subtract two polynomial functions, I still end up with a polynomial function, which I did. So it's a domain. Our real numbers, so negative infinity to infinity. Okay, number 3. Number 3. So f minus g at x was equal to 2x minus 11, right? Yeah. Let's find g minus f at x. Is it going to be g minus f at x? Is it also going to be 2x minus 11? No, because subtraction is not commutative. But I do know by definition that that's equal to what? What do I put first? G of x goes first this time. What's g? And there'll be g of x minus what? F of x. Same idea. What is g of x? G of x is not 3x. It's x plus 7. Okay, you got to make sure you write your correct functions. You're subtracting, right? So that's where you need to use that parentheses. What am I subtracting? F of x, which is 3x minus 4. One more step when you're done. What's the next step? Distribute. So I get x plus 7. What else? Minus 3x. And then plus 4. Combine like terms. Negative 2x plus 11. So g minus f at x equals negative 2x minus 11. I'm sorry, plus 11, excuse me. No, you're right. I'm sorry. I misread this. Plus 11. Now, I want you to remember something, guys. Look, when we did, let me find it. Okay, so when we did, going back to your previous lesson, look, when we found f minus g at negative 3, we said that was equal to what? 14, right? When I found g minus f at negative 3, what was our answer? Negative 14. It was just the opposite, right? Okay, so let's talk about something you learned last semester with factoring. What is the opposite of negative 2x plus 11? Positive 2x minus 11. So if you go back to number 2 that we just did, what do we have? Positive 2x minus 11. Okay, so it's just the opposite. So if f minus g was this, then g minus f is going to be the what? The opposite. And what's the opposite of 2x minus 11? All you do is change the signs. Negative 2x plus 11. But don't memorize that if you don't remember it. Just do the work. Do the work. Okay, what's the domain of this? Our real numbers. Domain of g minus f is negative infinity to infinity. Okay? All right, so we added, we subtracted. What's the next thing we're going to do? Multiply. All right, so number 4. Number 4. Let's find f times g at x. F times g at x. By definition, what is that equal to? Times g of x. F of x times g of x. Okay? Now, what's f of x? Yeah, now watch. I'm going to write like this for right now, just to show you what you're going to need to do. 3x minus 4. What's g of x? X plus 7. All right, see how I wrote it? That's the incorrect way to write this, because notice, what am I doing to those two functions? Multiplied. So I'm multiplying two binomials, right? So I got to put those in parentheses, put each one in parentheses. And now you know that you're going to FOIL this. You multiply two binomials, you FOIL. So what's the first? 3x squared. What's the outer? Okay. What's the inner? And what's the last? Negative 28. Combine like terms. You found your answer. F times g at x is equal to what? 3x squared plus 17x. And then what? Minus 28. What kind of function is f plus g at x? Yeah, but I want to use another word. Polynomial. So what's the domain of this polynomial function? Real numbers. I can use any number for x. Okay? And if I were to ask you about g times x, wouldn't the answer be the same thing? Because multiplication is commutative. 3x minus 4 times x plus 7 is the same as x plus 7 times 3x minus 4. Let's do division. F divided by g at x. F divided by g at x. All right, well, so by definition, what does that equal? F of x divided by g of x. What's f of x? 3x minus 4. What's g of x? X plus 7. And that's all you can do. You're done. There's your answer. You can't do anything else. You can't factor and reduce like you did last semester. Okay? So that's your answer right here. Now here's the question. What's the domain of f divided by g? No, you see, you got two. You got to look at your restrictions because in the previous ones you ended up with polynomial functions. This is not a polynomial function. That's a rational function. So this is rational now. And now you got to look at your restriction. What can't x be here? Negative 7. X can be negative 7. So you put negative 7 on the number line, cross it out. And so what's the domain? Negative infinity to negative 7 with parentheses, union negative 7 to infinity. Okay? See, now you ended up with a rational function. So you got to be careful. All right, let's do number 6, and I think we'll be done with this. Number 6. Okay, number 6. We have g divided by f at x. All right, well, by definition, what does that equal? G of x divided by f of x. What is g of x? X plus 7. What is f of x? Minus 4. So in the blank, you would put this rational, you would put this expression. All right, now the next question is this. What's the domain of g divided by f? Is it all real numbers? No. I kind of gave it away a while ago when I said oops. Because what kind of function is this? It's a rational function. That's a rational function. So you got to look at your restrictions. Where is the denominator equal to 0 when x is what? Look, all you do is just ask yourself, where's 3x minus 4 equal to 0? So 3x equals 4, so what does x equal? 4/3? So I can use any number except what? 4/3. So on your number line, if you need to, you put 4/3 and you cross it out on the number line. And so the domain of of g divided by f is, and you're going to say what? Negative infinity to 4/3, parentheses, union parentheses, 4/3 to what? Infinity. Okay? And so I think that should be enough for that worksheet. Okay, now let's look at these two functions. Let's suppose that f of x is x plus 8, and g of x is, let's say, x squared x squared plus x minus 12. Okay? Now, adding, subtracting, multiplying, well, multiplying is going to be a little bit tricky here because you can't use a fall method. But basically what I want to do is this. I want to look at f divided by g at x. So find, number 1, f divided by g at x. Okay, so let's do that. What's f? How do we write this? Divided by g of x. What is f of x? What is g of x? Okay, so that's where I'm at, right? So I found f divided by g. It's equal to this. Now the next question is this. What's the domain of f divided by g? All right, that's what you got to find. All right, well, what kind of function is f divided by g? Rational. So f divided by g is a rational function. How do you find the domain of a rational function? What must you find first? The restrictions. What makes the denominator 0? Well, that is not that simple because it's not linear. Your denominator is not linear. What's your denominator? Quadratic. But you still set it equal to 0. But now you're solving a quadratic equation. And these are factorable for us. So what goes here? Let's see. X, 4 and 3?
Yeah.
And 4 has to be positive, 3 has to be negative. And then you said each of these equals 0. That's a zero factor property. So x plus 4 equals 0, x minus 3 equals 0. So what's x? And what's x here? Positive 3. And so you found your restrictions. So on your number line, you're going to put them in order. You're going to cross them out, which means I cannot use them. So my domain is going to have how many intervals? 3. So you're going from negative infinity to negative 4, union to 3, union 3 to infinity. Okay? So when you do that back part of that worksheet, you have that quadratic. You're going to factor, and then you do the same thing. But on worksheet 3, if you look at it, go ahead and take worksheet 3 out. Okay, so number 2, let's suppose I want to find the product. Let's find the product. All right, what does f times g at x mean? Times g of x, right? And what is f of x? X plus 8. I put that in parentheses. And what is g of x? Yep. All right, so x squared plus x minus 12. All right, now, you want to multiply these two polynomials. You cannot use a fall method because these are not two binomials. So you have to use the distributive property. Now, here's how you do that. The way to do that is this. You take, how many terms are inside that first polynomial? 2. How many terms inside the second? 3. So you take each term that's inside the first and you multiply by the second. You take each term that's inside the first and you multiply by the second polynomial. So in other words, it's going to look like this. What's my first term here? That has to be multiplied by that second polynomial. So x squared plus x minus 12. Plus 8, and that has to be multiplied by what? That second polynomial. And what is it? X squared plus x minus 12. So you see what I did? So each term has to be multiplied by that second polynomial. Okay? Now distribute. What's x times x squared? X cubed. What's x times x? Squared. What's x times a negative 12? Okay, now do the next one. Distribute the 8. What's 8 times x squared? What's 8 times x? And 8 times a negative 12. 96. One more step and you're done. What's the next step? Combine like terms. And let's put it in descending order. So I get x cubed. All right, let's go by the x squareds. I have 1x squared and 8 of them. So that's 9. I have a negative 12 and a positive 8. Negative 4x. And then the only thing left over is your constant. And what is it? Negative 96. So f times g at x equals this. So when you have a binomial times a trinomial, you have to use a fall method. So you take each term that's in the binomial, multiply by the trinomial. That's how you do it. And basically, if you think about your two binomials, that's really what you're doing anyway. Watch. Let me show you. So if you go back to foiling, let's suppose I had 2x minus 3 times 4x plus 1, let's say. Instead of foiling, let's just use what we just did. Well, what we just did was this. We said that each term that's inside the first has to be multiplied by the what? The second. So that's 2x times what? 4x plus 1 minus 3 times what? 4x plus 1. And if I distribute, I get 2x times 4x is 8x squared. 2x times 1 is 2x, a negative 3 times 4x, and a negative 3 times 1. And I wanted to show you something. Watch. How many terms do you see here? 4. Let's FOIL. What's the first? Isn't that what this is? So there's your first. What's the outer? 2x. Isn't that what that is? What's the inner? Isn't that what that is? And what's the last? So rewriting as distributive, using distributive property is the same thing as FOILing. All right, and so you would get 8x squared minus 10x minus 3. Okay? So when you FOIL, you're really using the distributive property in a sense. Okay, now go back over here. When f of x was a polynomial function, g of x was a polynomial function. When you multiplied two polynomial functions, you ended up with a I don't want you to, for one thing, that's not a trinomial, right? I want you to say, I'm getting all kinds of things. I'm getting quadratic. I'm getting a trinomial. Although we all know that a trinomial has how many terms? 3. So that obviously is not a trinomial. I'm getting quadratic, which we all know that the largest exponent better be 2. This is not 2. That's cubic. What I wanted you to say, based on our discussions previously, is this. I have a polynomial function, f of x. G of x is a polynomial function. When I multiply two polynomial functions, I get a what? Polynomial function. So what's the domain? All real numbers, because it's a polynomial function. Okay? All right.
Brain's gonna explode.